Hi, my project this semester was a compilation of systems that are both Novae and Dwarf Novae. I am Ashley Dowd and my research advisor was Dr. Ashley Pagnotta. So some background, a white dwarf is a remnant of a star that was once like our sun, and a cataclysmic variable is a binary star system that contains a white dwarf and a companion star, which you can see down here with a white dwarf in the middle, surrounded by an accretion disk, and the companion star to the left. A nova is actually an eruption caused by a buildup of hydrogen on the surface of a white dwarf, which incites thermonuclear runaway. And a dwarf nova is an outburst caused by accretion disk instability. So in the accretion disk, the matter on its way to the white dwarf surface, hydrogen gas actually travels through this accretion disk, which is just a disk of hot matter orbiting the white dwarf, which you can see right here. Instabilities in this disk can cause larger than usual clumps of hydrogen to be transferred onto the surface all at once, which causes small brightenings that we observe as dwarf novae. And as the hydrogen gas slowly builds on the surface of the white dwarf, the pressure becomes high enough to incite thermonuclear runaway, and it causes larger brightenings, which are these novae. So our project goals were to catalog all existing CVs that have had observed nova and dwarf nova eruptions / outbursts, since something like this does not exist, to look for dwarf nova outbursts in current DASH data. DASH is data access to a sky century at Harvard. They have a huge photographic plate collection. It's basically just a huge sky survey, but on photographic plates, and to perform photometry on these plates and create a light curve. And then our other goal was to connect novae and dwarf novae to find potential evolutionary significance. Here are some of our methods. I'm not going to go into too much detail. We kind of had two parts of the project. The first one was compiling literature. We would find each target on the variable star index, then search the astrophysical data system to compile all the literature we could find on each star to get as much information on each target as possible. And for photometry, we searched light curves for each target, like I said, on DASH, downloaded the data and performed photometry and plot using Pelicans, which was designed for this project last summer. And on the right, you can see the VSX search engine and the DASH light curve search engine. These are the list of all our targets and the subcategories we found. Modern dwarf novae with historical record identifications, modern dwarf novae and ancient nova shells, which I'll talk about later, and modern dwarf novae plus modern novae. And we had one special case of an observed dwarf nova before the nova was observed and after. So this was all the information we wanted to gather on our targets. The right ascension and declination, the year of nova eruption, and the eruption amplitude, or how bright the nova got. T3, which is the time it took to decrease in 3 magnitudes of brightness. We needed a light curve shape, which we got from photometry or literature, in orbital period, the dwarf nova amplitude, the year of the first dwarf nova outburst, and the time between dwarf nova outburst and the nova eruption. This was our first target, AT King Cree. It is actually a modern dwarf nova plus an ancient nova shell, which you can see to the right over here. You can see it even clearer here in far UV. It is likely a few centuries old, and the first dwarf nova outburst was in 1974 with an average amplitude of 3.5 mag. Recent observations indicate outburst cycle of about 14 days. And we actually found 3 possible dwarf nova outbursts, which is really exciting, doing our own photometry and creating this light curve to the right here. You can see the first outburst here in 1897, and all of the information to the left here. This would be the second dwarf nova outburst and the third. Here is an example of the brightening, which you can see to the left here, and here's the target also less bright in its normal state, and this is the dwarf nova. So here are some of the graphs for conclusions we were trying to draw from relations that were theorized to have existed. So at first we plotted the orbital period versus years to outburst, since it was theorized that these two correlated in some way. Unfortunately, we didn't have enough data to see a correlation, as you can see here. So without finding a correlation, we plotted years to outburst versus the nova eruption amplitude, which we could not find any relation, and same with the dwarf nova outburst amplitude. No correlation could be found, probably because we didn't have enough data. So our conclusions: we could not find any obvious connections in evolution. We found 5 possible new dwarf nova outbursts, which is really exciting. These have never been found before, and we were able to find them in our light curves, and we actually just need more data to draw a better correlation between novae and dwarf novae, if any such correlation exists. Thank you for listening to my presentation.